I'm in this book, The Nemesis Affair, The Story of the Death of Dinosaurs and the Ways of Science by David M. Raup. I think that's how you pronounce his name. I want to dedicate this book to him. I just learned recently that he had passed away in July of 2015. It's unreal finding books like this at yard sales and at the library sales and things like that. And to look them up online and to find out that they've already passed away recently. 2015 is just last year. But it's kind of annoying if you think about it, because you read about him and you think, oh, what is he doing now? He's dead. Page 192. The process of arriving at a truth, or at least a consensus, is often a highly complex and rather disorganized business of backing and filling. It is a far cry from the stereotyped kind of science where a simple experiment or measurement establishes a discovery once and for all and without argument. I think that's very popular these days, to take the stereotyped science and expose it for what it is. It's a myth. There's no such thing as one single experiment establishes something and then everybody believes that thing for hundreds of years. It doesn't work like that. It takes many, many, many observations and many, many, many things all together, all at the same time, including social constructs as well, as we'll see here in a second. The scientific method, page 194. Almost all scientists think they know how science differs from philosophy, religion, and plain guesswork. Or at least all scientists I have talked to think they know. But it is quite a different matter to find out just how science differs from other forms of inquiry. To some, science is defined by the use of experiments to test the predictions of hypotheses. To others, it is any kind of careful scholarship not burdened by a prior commitment to a particular answer or belief system. Most scientists argue that religion is not science because religion involves no experiments, tests no hypothesis, and is committed beforehand to a set of beliefs. Science and faith are antithetical. It follows that scientific research is objective because the scientist is not influenced by prior expectations and is willing to let the chips fall where they may. I think these statements contain a fair amount of bunk. David here is dead and hit the nail on the head. He's completely correct concerning this. Guilty until proven innocent, same page. All sciences work within theoretical frameworks. These are alternatively called models, paradigms, hypotheses, concepts, principles, or precepts. Whatever they are called, they provide basic frameworks for thinking about problems and for interpreting observations. The Darwinian theory of evolution is an example of such a model or paradigm. The Nemesis Theory is another example, albeit at a quite different scale. Every field of science has one or more theories of this sort. The Nemesis Theory, just so people know, is the idea that there's a star that makes orbits around the sun every 26 million years, causing the extinctions of their periodicity, the periodic extinctions every 26 or so million years. So very different from electric universe, and the Velikovsky thinks Venus just ejected out of Jupiter, then caused one single extinction 6,000 years ago. The Nemesis Theory has it to where it's scaled as per what the extinctions actually look like over Earth's history. But anyways, in nearly all cases, the theoretical frameworks are thought up by imaginative scientists. They usually start out as little more than hunches, perhaps suggested by observational data but not required by them. The periodic table of the elements was not forced on chemistry by an immense weight of evidence that allowed no other interpretation. Page 195. Once a new theory or paradigm is proposed, it is tested and evaluated by the scientific community. Assuming it is reasonably credible and evokes enough interest, new or old observations or experiments are evaluated in light of the new idea. If they fit, the new idea is supported. If they don't fit, the new idea gets a black mark. Rarely is there a single crucial experiment to disprove or prove the new idea. All this is straightforward and has its counterparts throughout human affairs, but there is a tricky aspect. The new idea is almost never in a vacuum. One or more other ways of describing or explaining the same phenomenon already exist and are accepted by the scientific community. As I learned with stellar metamorphosis, there have been many scientists before me to prescribe the same kind of idea, to where a star cools and dies and becomes the planet. So it's not anything new. It's new to me. Okay, it's new to my listeners. Some listeners have thought of the idea themselves. Good on you. Okay. Walk up to an astronomer and ask, how was the universe formed and how old is it? You'll always get an answer, regardless of the decade or century in which you ask the question. Yet the answers change as new ways of interpreting the observations arrive and become established. If you'll notice there, new ways of interpreting the evidence. That's what changes. The evidence never changes. It's how we interpret it. When people look at the Earth, they say, well, it's solid and liquid material now, so it probably was always solid and liquid material, kind of like an extreme uniformitarianism. Things are like this now, so they were always like this. That's their interpretation of it. That's why geological sciences has the Earth as always being solid and liquid structure. But in light of the exoplanet data that's coming forth, we're realizing that Earth wasn't always solid and liquid material. It was very gaseous. And I'm making the preposition that Earth was not only gaseous too, it was plasmatic, because Earth is an ancient dying star. It's very, very, very old. It's a very old star, and its stellar evolution is the process of planet formation itself. But anyways, acceptance of any new theoretical framework depends on the credibility and improvement on existing alternatives. In cases where the choice is not immediately obvious, the burden of proof generally lies with the new idea. This is very important. Given a choice, the scientific community invariably sticks with conventional wisdom. Furthermore, the older ideas have usually been around long enough to have accumulated supporting evidence. Mind you, it's not the evidence that changes, it's the interpretation of the evidence. Whereas the new idea rarely has much going for it, at least at first, it is not a fair game. So what he's saying here is, sure, we have Big Bang, but it's been around for 100 years. Of course, they're going to find every little nook and cranny, every little bit and piece that they can try to force fit to make Big Bang make sense for 100 years. So naturally, if something new comes around in 2011, like it did me, and I find out that the objects in our solar system are older than 13.7 billion years, who am I? This is a new theory. I haven't had 100 years of evidence collecting to match Big Bang, so naturally the scientists, they're not going to look at my theory, they're going to go back on Big Bang, because that's what everybody has been conditioned into for 100 years. Despite the lack of fairness to new ideas, the traditional practice in science may serve us better than a more democratic mode. History shows that the most new ideas fall. Science would be very confused much of the time if all new ideas were given precisely equal treatment. I think what he means here is that the scientific community would be confused if all ideas were given equal treatment. Not science. Science is a method to me. It's just a method of coming to honing ideas. That's all it is. And as well, I don't think it's to prevent confusion. I think it's to make things easier for them. It's easier just to go to a textbook and say, look, this is how it is, rather than, look, it could be this, it could be this, it could be this, it could be this, it could be this. It's easier for them. So instead of saying, oh, it's to prevent confusion, I don't think they're worried about that. If they were worried about preventing confusion, they would get rid of unnecessary mathematical formulations inside of their astronomy papers that nobody really understands, if they were really concerned about getting rid of confusion. And to wrap up this talk, page 201, this stuck out to me. Mind you, this book was written in 1986 when I was a little baby. So it's pretty old. This concept has been around for a while. The Lunatic Fringe. Science is surrounded by a lunatic fringe which may strangely affect the progress of science itself. Perhaps once a month I receive a manuscript or privately printed volume from someone sporting a new theory of paradigm in search of a hearing. There are many such in evolution, earth history, astronomy, and I presume all fields of science. Their authors are typically untrained in conventional science, or their training is in a distant field of science. There are physicians, engineers, accountants, and a surprising number of independently wealthy business people. My impression is that they are nearly all honest and genuine people. Typically, they have worked for 20 or 30 years to marshal evidence for their particular idea. The tragedy is that virtually all the treatises they propose are a hopeless jumble of misinformation and logical error. One must be careful about such condemnations, of course, because it is always possible that the lunatic fringe is correct and everybody else is wrong. But the cases I am talking about are pretty obvious. And on that last note, he thinks if something's a lunatic, fringy idea, it would be obvious to him, which therein lies the problem. How do you know that it's obvious? Well, you only know what you've been told your whole life. So if something is obvious to somebody, how would you know, or obviously wrong, how would you really know? Because you don't really know. You've already been conditioned into a prior belief system. So there's that too, and obviously, if something's obvious, it's completely subjective. It's not an objective way of determining reality or what's true in nature. Today is September 5th, 2016. There you go.